Hello and welcome to the show. I'm Martin Willis, your host. And this is the Everything Else show, where I do a show about everything else, things that actually I have an interest in. And the show is done with random topics at random time. The easiest way to get a notification is to go here on our YouTube site, click subscribe, then click the little notification bell. I will be sending out actually newsletters about these shows. If you want to go on my website, which is podcastufo.com, you'll see a little newsletter thing on the sidebar there. So I was lucky enough to meet our guest a few years ago in Phoenix, Paul Hynek, the son of the great J. Allen Hynek, Project Blue Book fame. And Paul's personal lifespan has been increased recently by 10 years. And that was after he participated in a groundbreaking TRIIM trial and also a subsequent program after that. Now, the TRIIM trial was the first ever approved by the FDA. And it wasn't to combat disease, but rather to combat aging as a whole. And this was the first time in history anyone has tested by Steve Horvath's epigenetic clock test and actually tested younger than they previously had. And this was published in September 2019, the Aging Cell magazine. And I believe our guest, he just told me he was on a TV show, right? With William Shatner. What was that? When were you on that? When was that episode, hi, Paul?
Hi, Martin. Nice to be with you again.
Yeah.
So our TRIIM procedure was featured in an episode of The Unexplained with William Shatner last December.
Wow. I bet you got a lot. That must have sparked a lot of interest. Someone did tell me about that. And I said, no, it can't be the same. But there's not too many Paul Hyneks out there, I don't think.
Thankfully.
Yeah. So, Paul, there's the cat already.
There we go.
So much for a long life. It just crossed your path, right? But
anyway. I was born on the 13th, so I have that sort of superstition thing.
I see. You had to. So let's hear. This is great. So let's hear how you decided to try this. How you heard about the trial, first of all, and I have to tell you, I watched a TV show a long time ago, and it was I'm trying to remember I want to say his name was like Fahy Singh, an Indian from India, over 100 years old, running the marathon. Wow. And what was really interesting about that, when they were asking him, what he does to keep going and live as long as he has, I believe he was born in 1911. He's still alive. And that was calorie restriction. And this is all part of your regimen and what you're doing. And also, if I can, just a little bit more about that, which I think is very interesting. When they calorie restrict mice in a lab, they live about 30% longer, but they're miserable basically for life. but when they do intermittent, then they calorie restrict intermittently.
Yeah,
mice have a better life and they still live 30% longer. So there really is something to that.
Right. And, from my knowledge, there's not a lot of research that calorie restriction works for mammals. Really good evidence for mice. But I think there's more evidence that the de facto calorie restriction created by intermittent fasting, if you're not gorging in the hours that you do eat to make up for it, is actually more demonstrated to be more effective for mammals. So I'm not sure if the calorie restriction goes up to the larger creatures or not.
Oh, really?
Yeah, it seems like it's more a question of when you eat as to how much. And as you may know, with the TRIIM trial, calorie restriction is really not part of that. So we're encouraged to keep our lifestyle the same and not make sweeping changes to diet. But I've been an intermittent faster for some years now.
Yeah, I've done that. A lot of people have noticed that I've dropped a lot of weight, and I've over 40 pounds in about a year, and I've been doing the 23-hour fast, and I took 2 weeks to get used to it, and then I don't always stick to it, but that's really what I've done, and I feel more cognitive. I feel better overall, and it feels great to actually shed that, but also I feel like I look younger when I look in the mirror. I don't know if that's has anything to do with it. Maybe it's my imagination, but still. But I think you said that you've been doing that, but I also heard that stressing yourself, in other words, a little hot sometimes, a little cold, you keep yourself active, and these things will help you as well. What do you know about any of that stuff?
Yeah, so I'm a follower of Rhonda Patrick, who is a brilliant woman who's got a lot of videos online who talks about the benefits of saunas and other things that can generate the heat shock protein, as well as Wim Hof, who's the Iceman on the other end of the spectrum. So
Yeah.
I have a super janky home Chinese sauna, and I'll do that and then go into cold shower. And it's with so many of these health things, it's hard to attribute immediate causation to what you're doing. But the sauna, intermittent fasting just sort of seems to resonate with me. And the sauna and the cold shower, they just not only, well, the sauna feels good, the cold shower doesn't always feel good, but it really is bracing. And, there's nobody in the history of the world that's fallen asleep in a cold shower. I mean, it really gives you energy. And there's pretty good evidence that both the creation of the heat shock proteins and that cold, like you said, putting that kind of stress on the immune system in a way similar to fasting, tend to reboot the immune system.
Right now, as far as some of the things I've looked at over the years, when I've just been fascinated by this topic, is telomeres and how they become, they copy it themselves and they become shorter and shorter. And that's one of the things that, is recognized as aging. And I know there's something out there like telomerase or something that can slow down this.
Yeah.
And do you know anything about that? I know you're mostly in this TRIIM trial situation, but have you looked at all facets?
Yeah, I'm interested in all aspects. My good friend Aubrey de Grey, who's really well known in life extension circles, and Bill Andrews, who's also known, have differing views on whether you want to encourage or inhibit telomerase. And, for those listening who aren't intimately familiar with telomeres, it's basically the number of times cells can divide in your body. And that's kind of a hard stop. In some animals, some aquatic animals, they just keep going and they don't stop. So one of the keys to radical life extension is understanding how to increase the number of telomeres. I don't think there's any clear-cut consensus really on telomerase, which is the active component, and whether you need to inhibit or increase it. Now, we may get a whole bunch of comments that, of course, that's been settled, Paul. What are you talking about? I don't know, but I've not seen anything related to telomeres nearly as clear cut as what we're doing with the thymus, which is arguably the first and most important component of a overall life extension program.
All right, well, let's go into what the thymus is, and this is I put up some graphics because I realize that as you age, when you get between the ages of 60 and 80, it kind of changes to fat, and that kind of is one of the reasons that we die.
Yeah, and your thymus, as you showed it, I don't know how you got my actual thymus there from my doctor, but it's located behind your breastplate, right?
Yeah.
And it's what creates the T cells, which are thymus-enabled cells, which are your white blood cells, which is your immune system in action. And your thymus, it says involution there, which means shrinking. Your thymus actually starts involuting to the tune of 3% per year as early as age 20. So because evolutionary wise, at that point you've already had children and all that, and you should get on the outer reaches of the bonfire and leave the rest for the youngins. So the purpose of this original TRIIM trial, as conceived by Greg Fahy, is to actually regrow the thymus gland and make it functional once again.
And that is possible, you're saying?
Yes. And so I learned about this. I was already attuned to life extension. I just always felt since I was a kid that things like computers becoming aware, the singularity, and radical life extension would be possible in the not too distant future. Call it naive optimism, perhaps. But I just seemed like that just felt like it could be possible. So I was already predisposed to this. Then I came across Aubrey de Grey and got very involved with him and his work, where he looks at it in a very interesting way, that if you try to change basic metabolic processes, that's very difficult to do. On the other hand, if you wait until all of these things happen in your body, now you're just doing palliative care. You're giving Advil, you're doing things to reduce pain, but you're not really functionally increasing lifespan. So if you liken the body to a car, let's say, now if you buy a car, you can maintain it for virtually forever, just replacing all the parts if you take good care of it. So what Aubrey did was break down the basic areas of aging into 7 areas. And 2 of them are junk accruing or collecting in your cells, and also outside the cells in the extracellular matrix. So his idea is that, well, look, stopping that junk from originating is too difficult. Waiting until it's reached a critical mass and causes pathology is too late. What if we can essentially go in there periodically and scoop it out before it causes damage? That should have a lot of bang for the buck and be a lot easier. So I really like that approach. And is now called sens.org, SENS.org. And then I was already kind of primed. And when I was speaking at a conference called the Brink Conference about 5 years ago, Greg Fahy was another speaker, and he was announcing this trial to regrow the thymus. And he said, he had Greg is a brilliant guy and also very soft-spoken, but he had a very strong research foundation of other efforts that have come close to what he wanted to do in mice and in humans. And as you mentioned in the opener, it's the first trial ever approved by the FDA to combat aging as a whole and not this or that disease, and also approved by the IRB, the Institutional Review Board. And it was run under the aegis of the Stanford Neuroscience Institute. So he announced the sort of parameters, the age range, and that you had to be in very good health, and that you'd be tested, and then you could join it for free. And I thought, this is just amazing. And I went up to stage after Greg's presentation and said, Dr. Fahy, I was blown away by your presentation, and do all the testing you want on me, but I guarantee you, I will be in this trial.
How about that? Wow. So can you explain exactly what the thymus does and why it's so critical that has to be rejuvenated for longevity?
Yeah, it's basically think of like the heart is the engine of your blood and your circulatory system. The thymus is the equivalent for your immune system. It actually, I know I'm kind of glossing over a lot of details here. I'm a French major, so bear with me. But the thymus basically grabs regular cells from the body, and I say zombifies them into T cells. And these are the cells that will attack pathogens in your body. And it creates at least 2 kinds of T cells, let's say normal and naive T cells, which are especially effective at fighting unknown pathogens, diseases that you've not already encountered. And as you get older, and as you mentioned, the thymus both shrinks and turns more to fatty tissue and produces both less T cells, but especially less naive T cells. So as you get older in your 50s and 60s and 70s, your body is really less able to handle especially larger threats like cancer, for example. So the thymus really is your immune system. And there's been a lot of research, both done by humans and AI, that have sort of come to the conclusion that of all the things you need to do, telomeres, like you mentioned, stem cells, immune system, that the immune system is really job number one, because you can have as many telomeres as you want. If you don't have an immune system that can fend off the flu, you're going to die. So the immune system is really the first, and now perhaps not most difficult, because we've had some really good success with it, step along the journey to functional immortality.
Wow. Look who's in. We have someone joining us. How about that, Greg? Welcome to the
Hi.
show, Greg.
Hello.
Look, this is Dr. Greg Fahy. Thank you very much for joining us. So
my pleasure.
Yeah, we didn't know if you'd get the message or not, but here you are. I appreciate it. So we're moving along here. Paul has been describing. I know you're on a phone, but you're getting stabilized there. Yeah. We lost your audio.
Put you on speaker if possible, so I can hear you better.
Yeah.
But if not, we can manage this way.
Yeah. Why don't we do it this way? We have you.
Okay.
Yeah. So thank you for joining us. I know it was it was after the show started that you got the notification. But so you were the person behind this whole study and pushing it and all that. And Paul just told the story about you being up on the stage and him coming up and saying, "Okay, I'm in the study." That's one thing I know for sure. But
yeah, that was great. That was a great experience.
Yeah. So are you excited about the way things are looking?
Yeah, I mean, I'm never satisfied about anything, but yes, I am excited. We're reproducing a lot of the results that we saw in the original trial. We're trying to go beyond the original trial, add some extra bells and whistles. And not even Paul knows this, but we're looking at some new diagnostics coming up that may allow us to actually look inside your body and see how old you are. Nobody else has thought of this before, so we're really hoping that we can launch this pretty soon, but we'll be the first.
Wow. Now I heard Dr. Sinclair from Harvard on an interview, and he said that he could do a blood test and tell through some type of algorithms about when you're going to die. And that's something I really don't want to know. But I mean, unless there was a way around it. But does that make sense, or is that something that makes sense to you?
Well, yeah. So one of the main measures that we used in our study, which we tried on Paul, and Paul did well on this assay, is the Grim Age clock. So the Grim Age is called Grim Age because it's named after the Grim Reaper. Mm-hmm. And the reason for that is it was designed to try to predict how long you're going to live. And it's not a one-to-one relationship. If your Grim Age goes down by a year, doesn't mean that you're going to live 1 year longer precisely, but your mortality rate will go down. So your chances of living longer increase. So if you really work at that sort of a clock, yeah, you'd be better and better able to predict how long you're going to live. And I think one thing about that is that we tend to die not of anything general. We tend to die of things that are very specific, like a heart attack or that sort of thing, cancer. And those may be easier to predict than aging per se. So if you took into account heart disease and cancer, you'd account for about 70% of all of the deaths. The other 30% are due to immunosenescence, in my opinion. As a matter of fact, a lot of heart disease is probably due to immunosenescence, but we'll get into that later. So yeah, you could probably come up with a clock that would predict more or less how long you're going to live. So I think what Dr. Sinclair said is scientifically possible. I may not exactly know which clock he's referring to, but it is possible. He could have just been referring to the Grim Age clock, which is the same one that we used.
Okay. And Martin, Greg is too modest to say, but he knows David Sinclair quite well and has spent time with him. And David Sinclair has talked about our TRIIM trial in very glowing terms on air.
Oh, wow. Great. Well,
yeah, several times actually.
One of the things I want to do before we move too far into this is, I'm sure it's the average person listening, watching, or whatever, they're thinking to themselves, well, this is all great, but what can I do? What can I do to to live longer. Is there any, I don't know which one of you wants to tackle that, but I'm sure that's a question that comes to most people's minds.
I just need to have a little drink here first.
Paul's secret life extension. Wait a minute, Paul. Hold on, Paul. You gotta bring that into the camera a little bit better.
Oh yeah, right. Yeah. There you go.
Okay. And can you get that on eBay or something? Maybe.
Sure,
Yeah.
you can.
That doesn't surprise me that you went through all that trouble to do that, Paul.
Anything for you, Martin.
Yeah. So anyway, what can the average person do?
Well, there's a lot of things that you can do. All of the obvious things, of course. Try to exercise regularly. Don't smoke. Don't overeat. Don't drink too much. So all of the normal things. But then beyond that, there's some really interesting possible interventions that are accessible right now. One of them is to boost your NAD level. So there are molecules you can take that can be converted into NAD in the body. And we're not quite sure how effective they are at raising your tissue stores of NAD, but they're going to be better than nothing. There's also a product that some people have claimed is particularly good at that based on raising NAD levels in blood cells. I think there are things also on the drawing board that are more difficult to do, but still potentially possible if you get into a clinical trial. Of course, one of the trials is our own trial, which is still ongoing. So if you were to enroll in TRIIM-X, you might get the same benefits that Paul got or something at least analogous to those. There's another trial going on in the Bay Area in which they take half of your plasma out and replace it with salt solution. And if you happen to be a rat, that may work a little bit in terms of rejuvenating you. We're actually going to be looking at combining that with our treatment in the near future. There are other things that are, kind of interesting these days, but we're not quite sure what their effect is on aging per se, especially in humans. But alpha-ketoglutarate has led to pretty interesting results in animals. There are other things like spermidine that might be interesting to take. So I think if you look around, you'll find a few things that are out there.
What about there's I think it's called resveratrol.
Resveratrol.
Okay, and then there's a red wine molecule, the NMN. I know metformin is a prescription drug, and a lot of people use that for diabetes. I know someone that's using that. But can we talk a little bit about how important blood sugar balance is as well?
Martin, first let me say you mentioned resveratrol and metformin, and those are two of the sort of cocktail components of our TRIIM regimen. And metformin is a very interesting life extension type drug in its own right. But one of the reasons that we take that is one of the concerns about taking human growth hormone, which is the principal ingredient in our cocktail, is that it can cause insulin spikes. And Greg, jump in if I go too far off the reservation here. And so metformin, which has its own anti-aging properties, is designed to sort of tamp those insulin spikes. And there's also DHEA, resveratrol, vitamin D, and I think
zinc.
Vitamin K.
Yeah, vitamin K is being added as we speak, and Paul is not even aware of that yet. But yeah, we're adding that too.
Yeah.
So
there.
Yeah. So metformin, you mentioned in particular. Of course, that has received a lot of play recently because of Nir Barzilai. Nir has been trying to start a trial called the TAME trial, which is intended to force the FDA to admit and approve a drug on the basis of its slowing aging. So metformin is a pretty mild drug. You can get into trouble if you take too much of it, but if you play your cards right, it's relatively well tolerated. And in animal models, it does all kinds of things that indicate it may have some effect on slowing down the rate of aging. I don't think it reverses aging, but slowing it down is pretty good. And since we know that aging leads to all kinds of pathologies, slowing down aging should be something that the FDA would be interested in if the FDA could be convinced that it was possible. So the TAME trial is intended to show that people are taking, I think, 1,500 milligrams of metformin every day for about 2 decades or so will have a slower rate of aging, therefore less age-related disease. And if they can prove that, then they're going to have to, the FDA is going to have to deal with the fact that here's a drug that has slowed down aging in general, and therefore needs to be approved as an anti-aging drug. So that the actual purpose of the trial is not so much to extend people's lifespans a long time, but to force the FDA to recognize aging as a treatable condition. If that were to happen, then we could get our own treatment through the FDA much easier because, we would be able to show that there's evidence that it deals with aging through the epigenetic clocks, for example. Until something like that happens, then we're going to have to get approved on the basis of the fact that our treatment, in addition to reversing aging based on these epigenetic clocks, improves kidney function and has other benefits that you can point to that may extend your lifespan and reduce your risk of disease. For example, it seems to reduce the risk of prostate cancer. So if we could show that our treatment prevented prostate cancer or prevented kidney disease, maybe the FDA would approve our treatment on that basis. And then, of course, people would take it for the general anti-aging effect, but it would be legal because you could prescribe it off-label for these other endpoints.
Mm-hmm. Now, if you think about it, we're built more or less through evolution to last just a certain amount of time. We breed, we carry on the species, that type of thing, 20, 30 years old, something like that. And then it's kind of all downhill from there. But in your opinion, if we could address everything that can be addressed, how long do you think a human could live, sustain with brain function, normal brain function?
It's really hard to answer that question because we don't have the kind of baseline data that we truly need for that. For example, Bruce Shankner at Harvard has produced evidence that age-related changes in brain function may be related to the accumulation of mutations. But I've generated some evidence that mutation accumulation is an active process. In other words, that it's activated by events that take place before the mutations occur, such as the reduction of DNA repair pathways. And so we don't really know what would happen if the reduction of DNA repair pathways never took place. All we can say is that there are people that make it to the age of 100 with their mentation in pretty good shape. Even people who live to 110 can still think and function at some level. What would happen if they had never had that handicap of having their brain aging programmed starting from maybe the age of 20 or 30? They would probably make it to 200 or 300 or longer. Who knows? So we don't have a lot of information. I will say that, there was this interesting experiment that was done a long time ago in which they found out that if you starve a worm, it gets younger for a while. And then if you refeed it, it starts getting older again, but then you can starve it again and make it younger. And by yo-yoing it back and forth like that, they were able to extend the lifespan of the worm. It's actually a beetle now that I think about it, but it was a larval beetle by a factor of 13. Huh. So that would be, the equivalent of a human living to over 1,300 years or so. And the worms eventually didn't die. They did die, but they didn't die of aging. They died of a design contradiction because they were never intended by nature to live that long. And so they had another issue that in normal life would never be an issue. But once you live 13 times longer, it eventually builds up. So in addition to aging per se, we may have to look at design contradictions like that eventually. But we'll have plenty of time to figure that out as we go along, I hope. So I just would say that if we didn't die of all of the causes of death that are part and parcel of aging these days, I think we would live a very long time. If statistically, the lowest mortality risk that you have is about the time you go through puberty. It's all downhill from there. And before puberty, you're too young, you're vulnerable. But when you're about reaching your sexual maturation point, you're pretty robust as an individual. And if everybody could go back to that sort of optimum uh, defense against age-related morbidity, mortality, we would have about a half-life of somewhere over 900 years, like 930 years, something like that. So that would be based on the accumulation of accidents as a cause of death. But of course, once we live to 900 years, we'll probably be more careful about avoiding accidents too. So I would say there's no obvious limit. I think in principle, we should be able to push things out quite a distance. But of course, we have to start somewhere. So that's what Paul and I are trying to do now.
Yeah, and I think we're knocking on the door of, call it lifetime escape velocity or functional immortality, where we can repair, like Aubrey de Grey says, things like mechanics in the body and scoop out that junk in the brain that Greg is talking about. And
yeah,
the real
I mean,
for
we
us
just don't know. I mean,
will be
theoretically, according to our clocks, Paul is
right.
younger now than he was 5 years ago.
Wait a minute. We got two people talking here.
Okay, sorry.
That's all right.
Yeah, it won't. The threat won't be so much from internal, because we're getting a better handle on that. It will be being run over by a bus, things like that. So the real challenge after working on telomeres and clearing out the brain and the thymus is really then the harder step of uploading and having a backup for whatever you consider your you to be, because the failure point is being in this substrate. And we're shoring it up really well, but that's still what's going to be the glaring weakness in 100 years.
Wow. Yeah.
Yeah, and you wouldn't necessarily even have to sort of upload yourself into a computer if you could distribute your consciousness over a large volume of space. Since light travels very rapidly, you could sort of smear your consciousness over, say, a planetary scale, which would make it very hard to be killed by any discrete event happening anywhere on a subplanetary scale. So there's all kinds of interesting possibilities for life extension in the future once we overcome the initial problems we have now.
Martin, he's giving a great segue to UFOs there. Are you going to run with that?
No, you can do that. I was just thinking how cheap life insurance would be if we could live that long.
That's true.
Yeah. So it's funny. Someone mentioned something about Keith Richards. That is pretty funny, I have to say. I want to talk about jellyfish. You must have heard about what jellyfish can do. They can basically die and be reborn. I mean, I don't know if you've looked into that at all. Have you ever heard about that?
I'm not sure about the dying and being reborn part. I think I may have heard of that. There are organisms similar to jellyfish that never age because they can regenerate their body parts at all times, like hydras, for example. They're related to the jellyfish. But I think I may have heard that story. But perhaps you could refresh the two of us and your audience about it.
Yeah, I think you may be closer to it. Like they can just regrow themselves.
Yes.
Yeah.
But yeah, before I go off on a topic like that, I should. They just do like a complete regeneration or something like that. It says right here. I'm just reading. When they die, they sink to the floor and they begin to decay. Amazingly, the cells reagitate, and but anyway, I think what I'm getting at by just mentioning this at all is I think that's another point of research, something that can do this type of thing.
Yeah, I think regenerating new cells is not really much of a problem in theory. We have stem cells that reproduce other tissues in the body, and as long as the stem cells keep producing new tissues, you can turn over tissues indefinitely in theory, as long as you can keep the stem cells happy. And there's a lot of technologies coming along for that. But it's the brain that you have to worry about, because we can't turn over the brain in the same way, because we have memories that we want to hold on to in the brain. But we don't know a lot about how that works. I can tell you that the brain does turn over, and yet the memories stay there. So I think the brain is clever enough to be able to do housekeeping and turn over damaged molecules and still retain the memories in some way. And it's a very, very interesting question. But if that's the case, then perhaps just augmenting or maintaining the current turnover mechanisms that we already have would allow our brains to function pretty much indefinitely.
Mhm.
There may be an issue as to whether there's a finite memory storage capacity in the brain. But like I was saying before, if you can have a lot of brain atrophy and still have good cognitive function out to the age of 110, then how far could you go if your brain mass was conserved perfectly? Instead, you could probably go out at least to 400 years. So I think once we get out to ages like that, then we'll, have more time to pay attention to that as a possible limiting factor.
Now, what about releasing endorphins? It's like stimulating parts of your brain and things like that. That has to be a positive effect?
Well, sure. So, I think what that touches on with respect to longevity is that people who are happier live longer than people who are unhappy. People are having a good time want to continue to have a good time. And it's not just psychological, it's also physiological because our brain talks to our body. We have things called stress hormones that don't do us a lot of good in the long run if they're activated all the time. And when we release oxytocin, we feel good and warm, fuzzy feelings. And it turns out that hormone also is related to preventing aging as programmed by the hypothalamus. So, I think if you feel good, you're going to do better. And if you do better, you're going to feel good. So it's kind of a positive cycle.
Yeah. I've had one of those years, even though it's been COVID, I've had things really nice happen this year that I feel really good about. So I feel like I'm going to live longer.
Good.
Yeah. So one of the things also I was thinking about when we're looking at the different things that people can do is, Paul, I heard you mention a hallucinogen. I believe it was when you were on my show, and I'm trying to remember what it was. It's DM. What was it that you had taken at one time?
Yes, DMT, and this is not
DMT.
part of the TRIIM trial. Let me just maybe,
That's right.
Maybe I can lobby for its inclusion in a subsequent trial, but I've got a little bit of a hurdle to get over with the esteemed Dr. Fahy on that one, I think.
We'll have to have a talk about that.
Yeah, so DMT is well, I guess I could make the connective tissue here in terms of serotonins and endorphins and being happier living longer. I think that's sort of a tenuous connection, but in my experience, psychedelics can have a profound impact on someone's outlook on life, feeling more connected or more relaxed, etc. And DMT is a really, I think, intriguing substance that's in a class apart from other psychedelics that I'm aware of. It's stronger and it's also more natural, occurring, is secreted by the pineal gland in the human brain, and it's sort of coursing throughout the natural kingdom. And for me, what's very interesting about it is that in reading a lot of the research reports of case studies or of user reports, it kind of echoes the early days of UFO reports in some of the patterns emerging of some of the archetypes of things that people report that they experience.
Wow. And what about, I watched this great show. I love to watch these documentaries. And there was one called Fantastic Fungi or Fungi.
Mm-hmm.
I don't know. That was absolutely fascinating to me, and how interconnected everything seems to be in so many ways. And
they feature Paul Stamets, who is the sort of fungal hero of the world. And one of the interesting things, to your point, Martin, about connectedness is that, let's say you have a forest. Underneath the forest floor in the ground, there's a mycorrhizal network that's sort of a fungal router that connects to all the trees and channels resources to trees based on seasonality and their particular needs. And it's a living organism that is localized intelligence without any man-made interference that is sort of helping the individual organisms in the forest.
It's just amazing. Just amazing. And I think we're going to know more and more about that, as time, the more the study that goes into it. There is something up here because the average person, a lot of people may feel this way. This is a text I'm putting up here from Raphael. What good is living longer if your body begins to fail? Why bother?
I think if your body begins to fail, you're not going to live longer.
Okay. So address.
I think it's just that simple. Yeah. Right. That's not what we're talking about. We're talking about keeping your body healthy and therefore extending your longevity as well.
Yeah. Yeah.
So
yeah, I think and Greg and I have heard this kind of question before, like, why would I want to live an extra 30 years in a wheelchair or on a ventilator? We're talking about a still hopefully short morbidity period, but a much longer period of vitality.
I see. Yeah. I mean, it's always about the quality of life. Mm-hmm. I mean, who wants to live miserably, So, and I think it's important, the number one thing I would imagine you would have to say here, the number one thing is taking care of yourself. And what does that mean? Diet, exercise, don't smoke. I know there may be people listening right now that smoke. It's not going to do you any good. I mean, you think of what it does to your skin, for one, how much it ages people and just the, the skin alone. But also, and get the right nutrition. What else is there for the average person? Exercise, of course, is really a big thing in that as well.
When you hear somebody who, Greg already said that you're brilliant and soft spoken, when you hear somebody like Greg Fahy, who does not sort of go out on a limb, actually bandy around centuries of possible lifespan, we're on the cusp of far greater lifespans. So you really want to take care of yourself. It would really be a shame to be the last generation or the last individuals that smoke themselves out of getting on that bus of lifetime escape velocity.
Right. And, going back to the amount of time we're supposed to live, when you mentioned, Greg, I believe you mentioned that your body, things start to change right after puberty, which is really pretty scary. It's kind of all downhill from there. Is it all downhill in your entire body or just parts of your body or brain?
Well, in terms of certain things like muscular strength, you continue to get stronger and you continue to grow to some extent after puberty. So in some ways, you're becoming more powerful and more formidable as an organism. But at the same time, your immune system is beginning to go to hell. As you go through puberty, it triggers the destruction of your immune system. And eventually that catches up with you and starts dragging the rest of your body down with it. Also, as you go through puberty, you reduce growth hormone and you reduce DHEA. And it turns out that growth hormone, although it's sort of a double-edged sword, is necessary for maintaining all kinds of functions as you get older. And DHEA as well does things like help you not get fat, and so as DHEA goes down, you're subjected to more and more problems. So it seems like it all sort of stems from puberty. That there are interesting cases, in the scientific literature in which if you prevent puberty, you can prevent aging. That worm experiment that I told you, in which the worms are able to live 13 times longer than normal, that was accomplished by preventing them from actually becoming adults. So, the Peter Pan story had some merit to it. If you don't become an adult, you may not age. But since the adult body has exactly the same genes as the young body, you still know everything you need to know to stay young when you're an adult. It's just you're not using that information anymore. So if we can turn that information back on again and maintain your sort of life maintenance systems the way they were when you were young, you should, again, go down to a mortality rate that's affected much, 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 much less by aging, if not, if anything at all by aging.
And what about antioxidants as far as the type and other types of food that works pretty well for like at least slowing down aging? Is there such a thing?
Yeah, so Paul may want to comment on this too, but for many years, the American Aging Association was led by a guy named Denham Harmon. And Denham Harmon, I used to know, he was a nice guy. He invented the free radical theory of aging. And Dirk Pearson and Sandy Shaw used to go on the Merv Griffin show and talk about how using antioxidants would extend your lifespan, according to Denham Harmon's theory. And so Harmon started off early in his career by extending the lifespan of rodents by 50% by feeding them BHT, which is an antioxidant that's used to preserve potato chips. And so the thought was, well, if it preserves potato chips, maybe it will preserve me too. But since then, there's been a lot of work done. And in particular, the research done in the laboratory of Arlen Richardson in Texas looked at various genetic mutants in which antioxidant defenses. So, you can eat BHT, but that alone is not the main defense that you have. Most of your defenses are built in. So you have enzymes that get rid of free radicals and other oxidants. And you can knock those defenses out through genetic mutations and see what happens. And what you see in every case, and he did like 20 of these mutations, is that, all of these oxidative damage products accumulate when you do that. And there's absolutely no effect on lifespan whatsoever, with one exception, and that was catalase expression in the heart. And that turns out to be artificial. So the evidence in favor of the idea that we age because of free radical and oxidative damage just really isn't there. But of course, you can always point to specific cases in which there's a benefit. So I advocate, taking multivitamins, taking vitamin C, vitamin D, vitamin E. All these things are good, and they do have antioxidant properties. But the irony, the deep irony that has finally emerged after decades of people thinking about this, is that the true cause of aging is too little oxidation, not too much oxidation. And this came out of David Sinclair's lab when he discovered that a major driver of aging is a molecule called NAD. And NAD exists in every cell in your body, including your red blood cells. And without NAD, we'd all die in probably several seconds. And what NAD is it's an oxidant. And it has a partner, NADH, which is a reductant. So NAD and NADH are a pair, and NADH gives you reducing equivalents to help you make things like proteins and other things. But without the flip side of that coin, the oxidizing side of that coin, you would die. And as a matter of fact, it's the reduction in NAD with age that probably drives a great deal of the aging process. And so, the really interesting thing to do nowadays is to figure out how to raise your NAD level so that you can come into better balance and sort of reverse your aging programs. So, short answer to the question is the big part of the story is that you need more oxidation, not less.
I've got nothing whatsoever to add to that. But one thing I like to say that's a part of our trial is that we're still in the era of generalized medicine. Take multivitamins, do this. And we're soon going into, we already see a lot of efforts of much more personalized medicine. And one of the really important benefits that I get as a patient or as a participant in the 2 TRIIM trials so far is Greg's, imagine if you have the best doctor you've ever had in your life who pays more attention to you than any doctor ever has in the form of voluminous emails, and not in service of eradicating whatever complaint you have, but of radically increasing your life and checking. I don't know how many blood tests I've done in the last 12 months, 13, 14 or so. So you're monitored all the time for your individual characteristics. And then each part of our treatment regimen is carefully calibrated. So you really feel like you've got one of the best medical minds in your corner spending much more time on your case to really help your health. And I think in general, we're moving more towards that with much better diagnostics of the microbiome and other markers in your body, so that we will know how much vitamin D do you need, vitamin K, NAD, etc. And that will be a big boost in health for everybody.
Do they study centenarians? They always say, it's people that they'll say, oh, it's longevity is in the genes. I don't know. I mean, that's what you hear people say. But
yeah, there are various individuals that study centenarians. We've learned a lot about aging from studying centenarians. We find that centenarians are different kinds of people. They don't get sick, or some of them get sick, but it doesn't affect their longevity. They just deal with it. They just handle it. And their offspring show similar features. So when they get married and they have kids, some of their kids inherit their genes, and those kids seem to do better than the average 80-year-olds of the same age as the offspring of the centenarians. And you have super centenarians as well. So I think what these people teach us is that there are biological tricks that can deal with aging to a large extent. Of course, not to the point of immortality, but certainly much better than the average population. So the more we learn from them, the better we'll be able to handle aging for ourselves as well.
All fascinating. This is all very fascinating. John wanted me to ask you about the use of hyperbaric oxygen chambers.
Yeah.
So,
well, I find these very interesting, and there's actually one not too far from where I'm located in Southern California, and I do plan to pay a visit to that. So I have a theory about hyperbaric oxygenation. So there was a story recently that came out of Israel because they claimed that they were able to make cells younger by putting people into a hyperbaric oxygen chamber. What they were referring to is that they made measurements that indicated that the telomeres were longer in the people that went in the hyperbaric chamber. That was refuted by Bill Andrews, who's probably the world's leading expert on telomeres these days. What he said is that it's been shown for a long time that hyperbaric oxygenation will kill senescent cells that have short telomeres. And of course, that means that the cells that are not killed have longer telomeres. So when you measure telomere length, it looks like they actually increased, but they actually did not. So there has been some hype about these chambers recently, and I believe there's been more that has come out since that initial study. And I have to confess, I'm not totally up to speed on all of it. But my theory about it is that it offers some really interesting potential for reversing aging, because what does it do? If you go into a hyperbaric oxygen chamber, you're getting more oxygen. And what is oxygen? Oxygen is an oxidant. And so it's going to convert your NADH into NAD. And that means your NAD will go up. And we've known from Sinclair's studies and many others that if NAD goes up, you should get younger. So this is one of the things that I would like to test. We can actually measure aging now with these epigenetic aging clocks. And we think one reason that our trial showed aging reversal in people like Paul is because our treatment through immunological mechanisms rather than hyperbaric oxygenation mechanisms had the same effect of increasing NAD in the body stores. What would happen if we could combine that immunological mechanism with another mechanism like hyperbaric oxygenation? It could be very exciting. So far as I know, nobody has pursued that idea or even thought of it other than myself. But it's something that we will learn more about as time goes on.
There's another sort of home technique for oxidation that I've come across and run by Greg, who didn't poo-poo it, which is that, we talk about like breathing and how you need to breathe a lot to get oxygen. But part of that process is that you have to get rid of the CO2. And that for some people, breathing in too much oxygen too fast can actually retard the process of getting rid of the CO2. So you functionally have less oxygen. So, if you have the thought experiment of you have a very overweight person and an athlete, and they run up a couple flights of stairs, what do you expect them each to be like? The one that is very overweight, you're thinking that he's huffing and puffing, but the athlete who's finely tuned needs less oxygen. So it's no question that you need more oxidation in the body, but because of the two-way circuit, it may be that a more regulated flow of oxygen in the first place may help actually with the overall process.
Mm-hmm.
That's actually kind of interesting. And, depleting carbon dioxide levels too much can actually cause vasoconstriction in the brain. So, as usual, there are complexities involved in everything, including this.
Uh-huh. There's some questions coming up on chat, and I can actually take calls in a little bit. But I like this one in particular because, I kind of lost a lot of my hair. And, is there anything? I know this is probably totally separate, but this Iris saying, how can I prevent my hair from becoming gray? I think that's a great question, because that must be a chemical change in your body that makes something like this happen.
Well, one thing that can cause hair to become gray is a copper deficiency. So make sure you're not deficient in copper. That may help. Another interesting observation of our own study in TRIIM was that a couple of the guys had their hair, which was previously white, start growing in dark again. So there may be, there may be something about our treatment that helps with that.
Wow.
My brother Paul was also in the initial TRIIM trial and is in this trial as well, which just ended. And he felt that his hair did get darker during the trial, and his wife confirmed it.
Wow.
Yeah. Do we have some photographs that we can pull together to prove that, Paul?
Yeah,
you think?
I don't know if you can do it now, Paul.
Let me check.
All you have to do is email them to me if you haven't, Paul. But one of the things you do have to say, though, too, people have to be careful about copper. You can take too much copper, too. And that can be
be careful.
That can be very bad.
Yeah.
Yeah.
No, I'm glad you pointed that out.
Yeah.
I hate the idea of taking copper, but I've had to have another look at it lately because it does have a lot of benefits. So it's something not to neglect.
Yeah, you just have to take the right amount.
Yes.
I love this question.
By the way, just to clarify that, what I understand is that you get into trouble with 10 milligrams and above, but for perspective, a normal day's food intake will give you about 0.9 milligrams. So you have to eat about 10 times the normal intake before you start getting into trouble. And I wouldn't recommend getting anywhere near 10. But, if you took a couple milligrams a day or every other day, you ought to be safe.
Will it regrow hair too?
Well, I don't know about that. But there are drugs like Rogaine that allegedly can regrow hair.
Yeah. I know. I'm just kind of messing around here.
Yeah.
Paul, this is a great question. We know you test at this point about 10 years younger. Do you feel younger?
So when we kicked off the initial TRIIM trial at Stanford, it felt like a grand experiment, and I dubbed us the Thymonauts. And we're all very excited because it was such an impeccable presentation that Greg put together. One of the questions I had was, okay, you've shown a very strong research base that the thymus can be regenerated, but how will the overall signal pathway function? For the first time in history, the thymus is back online. Will the rest of the components know and say, hey guys, the thymus is back online, let's go. And it turns out that it is the case. So we were all very excited when Greg answered all these questions, and our group was emailing everybody. And some of the other fellows in the experiment were saying, I feel like I'm 18 again. This is fantastic. And I sheepishly emailed to Greg saying, Greg, I really don't feel any different. I don't know if this is working. And Greg emailed me back and he said, well, you're in pretty good health, Paul, so you're probably not going to feel much different. And indeed, I really haven't felt, it's not really so much about vim and vigor. It's about not getting sick and sort of internal components. So as I mentioned before, it's hard to pinpoint cause and effect when you're doing a lot of things for your health, but I really don't feel different. I feel less sick. I don't get sick very much. But I can't say that I feel a lot different, which is not really the primary thrust. But and Greg,
But in a way it is, Paul, because if you had not been maintaining the same age or less for the last 5 years, you might feel worse.
yeah, there you go. There you go.
So it's not just a matter of whether you feel better, but not feeling worse is pretty positive as well.
Yeah. Wow. Yeah. That's yeah. You may have been really sick right now if you didn't do any of that. So speaking of health, what kind of, if someone wants to get into your trial, and one of the questions I keep forgetting to ask, what is TRIIM? Hold that question first. I want to know what type of person can get into your trials, and what type of physical shape do they need to be in, and what type of testing do they have to have?
Sure. Before I answer that question, I'll just note parenthetically that my cell phone tells me that it's near the end of its battery life here. Okay. I'm not plugged in. So
how ironic for a discussion on extension.
Yeah.
I need to extend the battery life.
Your battery life. Yeah, you need to put that in the TRIIM trial too.
But I'll answer you with whatever time I have available here. So TRIIM stands for Thymus Regeneration, Immunorestoration, and Insulin Mitigation. So the purpose of the trials was to regrow the thymus and restore immune system function without elevating insulin, because insulin goes up with aging, and it's a pro-aging factor. It's a side effect of growth hormone, so we wanted to block that. So the answer to the second question, which is what does it take to get into the trial, you have to be generally reasonably healthy. If you're going to die of a heart attack in 5 minutes, it's useless for us to put you in the trial, because you're going to make us look bad, and we're not going to learn anything from you because you won't finish it. But if you're in reasonable condition, then you can get in. The main exclusion is having a high risk of cancer, because we're giving you a bunch of growth factors. And if you have cancer already, we don't want to make it worse by making it grow fast. So if you have ever had cancer in the past, we actually can make exceptions. If you've had sun-induced skin cancer only that has been removed, a few years ago, and you haven't had any recurrence, that's not something we consider to be an actual intrinsic cancer risk that you have. But if you're genetically predisposed to develop cancer, or if everyone in your family has died of cancer, or if you've had cancer several times in the past and it's not just skin cancer, it's something more serious, we're just not going to take the risk on you. We don't want to do any harm to anybody in the trial. The FDA has prevented us from enrolling people who have type 2 diabetes, and that's reasonable, because we're going to make you more like a type 2 diabetic. And if you're already a type 2 diabetic, it's going to be harder for us to overcome that. And so we can't let you in. But
what about type 1? Pardon me, what about type 1?
Type 1 is theoretically okay. It's theoretically okay because you can be controlled on type 1.
I see. Interesting. Yeah. So I kind of interrupted you there. If you want to keep.
One of the things, Martin, to mention is that people can come to the website. I'm now the CFO of the company, working with Greg and Bobby, our CEO. It's interveneimmune.com, where they can learn more information and see Steve Horvath also, who you mentioned. One of the things, it's not something to do lightly. I think it's overwhelmingly positive, and Greg knows I'm the biggest poster boy there is for this, but it is a commitment, because it is to really do it right. It's a year-long program where no major life changes, but you have to be conscientious about the program. So it's not just like adding a new supplement every morning. It's a bit more involved, but it's like I mentioned, you have the benefit of having one of the best medical minds in the world dissect your case with CSI-like precision and give you the roadmap to lifetime escape velocity.
Yeah.
Yeah, it does take commitment. You have to inject yourself with, growth hormone 4 times a week. You have to have certain meals, that you standardize before you get your blood drawn. So there are certain things you have to do in order to be in the trial, certain behavioral things that you have to be in touch with. But overall, you do learn a lot about yourself, and ultimately, we will learn a lot about how to deal with aging in general. So we certainly welcome anyone in who's interested in this study.
And it's really one of the few things I've come across that has demonstrable results. And Greg, I mentioned the publication in Aging Cell magazine.
Yes.
We got clear-cut results that Greg has shown both in that article and at numerous conferences.
So what do you see for, we can probably just wrap this up while you have battery left here. So what do you see for the future? I mean, this is exciting. I consider this being on the ground floor. What do you think's the future? I mean, the way we develop, the way we, science changes all the time. I understand we know so much more about the brain than we did just 10 years ago. We make leaps and bounds. And I think aging is important enough where there's going to be a lot of people that are going to want to invest a lot of money if it looks promising.
Yes. So there are many exciting developments coming along: NAD therapy, the TRIIM treatment, plasma dilution, all kinds of stuff coming along. Maybe hyperbaric oxygenation, if that works out. Maybe some of these other things that we talked about, like alpha ketoglutarate. Who knows about that? We're going to be starting to combine these things. There's also a treatment called E5, or it used to be called Elixir, which has radical anti-aging effects in rodents. And I'm friends with the people that are promulgating that, and we would love to combine our treatment with their treatment at some point to see if we can rejuvenate people even better than we already have. So I think that the one beautiful thing is that also senolytic therapy, getting rid of these so-called zombie cells, in lice, in rodent models, if you kill off these zombie cells, the animals get healthier and live 40% longer. So all of these things, the beauty of them is that they're compatible with each other. None of them are a contradiction to any of the others. That means that they may be additive. We may be able to do all of these things at the same time and just really have a totally profound effect on aging. And this is not something in the distant future. I'm talking about things that have already been seen, already been learned, already been demonstrated. What has not been done is to see what happens when you put these things together. So I'm very, very excited about that. And as I said, we're developing new diagnostics also, so we can investigate how well these things work more easily, more comprehensively, and more palpably, in a more visually exciting way. So I think the near future is going to be very exciting. Next 5 or 10 years should really be game changing, I think.
And Greg, with my permission, can you, for the benefit of the listeners or the viewers, characterize the results I had to make them sort of concrete so people can know what they might expect if they join our trial, which they can do, John Burbridge, by coming to interveneimmune.com.
Yeah, so I have to review your case in more detail with some of the endpoints, Paul, but Paul took his grim age back, I think, around 11 years. So, in our study, we published that on average, people were 1.5 years younger at the end of the trial than at the beginning. But that's an average, right? So some people didn't do quite as well, and there are a few people that did really outstandingly. So Paul is one of those people that just kicked it out of the park. I think he went back 11 years by grim age, which is awesome. But he also went back by about 11 age in terms of this plasma pheno-age clock. And then we checked him 4.5 years later, and he was a little older by that clock, but he was still 4 years younger than he would have been if he had not participated in the original trial. And then he went on the TRIIM-X and added another 5 years on top of that. So Paul has done quite well, and currently, at least based on the plasma pheno-age, which is the only one we can measure on the fly. The other ones we have to wait until the treatment is over to get a measurement. But based on that one clock that we can measure on the fly, Paul is now younger biologically than he was basically 5.5 years ago. Whereas 5.5 years ago, he was biologically 3 years older than his chronological age. So, we've actually pulled him back in time quite a bit. And so if we can do that for Paul, we can do that for others as well. So I think there's a lot of exciting things that we can look forward to.
Right. Now, one thing I do have to ask you, because you see a lot of older people, and like my father was 6'2". By the time he was 80 years old, he was about my height, which is several inches shorter.
Yeah.
So what about that? The type of, the breakdown of the calcium in the bones and things like that. Is there a way to, I mean, you could maybe live longer, but do you get to every cell of the body?
You do, because growth hormone goes everywhere. It touches virtually everything. DHEA goes everywhere, it touches all kinds of things. Metformin will improve the general milieu in your body, which is our third component, by preventing insulin insensitivity from developing, which affects almost everything. So, and those are their separate effects. When you put them together, there's going to be synergy, right? So I think what we're looking at is arresting those processes that you're talking about. So why do we get shorter as we get older? It's because we don't have growth hormone. If we put growth hormone back in, we're going to stop getting shorter, because we're going to reverse that process of not, sort of anti-growth, you might say. That's why little old ladies are little and old and lady. I mean, they're little because they're shrinking, because they're losing bone mass and muscle mass and everything else. And if you extrapolate that forward, of course, you can't achieve a body mass of 0 and stay alive. So if we stop that by sort of rebuilding the body instead of letting it go downhill, we're likely to have a better outcome. But can you reverse everything? We don't know. For example, if you have very bad arthritis and your joints are very gnarly and everything, we may improve the health of those joints. We may prevent them from getting worse. But whether we can actually reverse, bone overgrowth, that's a different story. Maybe not. But one of the things that growth hormone does is it regenerates cartilage. So why do your joints get so bad in the first place? It's related, at least, to the destruction of the cartilage in the joint area. And if your cartilage was preserved by, for example, taking growth hormone, you may never get gnarly in the first place. So that's what we want to do.
Interesting. Wow. And let's see, there was a question. Someone wanted to know, here it is. Is there an age demographic? Like, for instance, if you're over 60, don't bother. I mean, does that happen? I mean, do you have that?
That's a really great question. So I want to sort of, on the chance that we have very little time left, I'll just give you the most punchy answer to that question to start with. And that is, every cell in your body still remembers how to be young. All you have to do is remind it. And so we know this because you can take any cell in your body, even if it's 85, and turn it back into a 20-year-old cell in 24 hours by just adjusting gene expression in that cell. That's been done at Harvard in a way that took an 81-year-old skin cell or so and took it back to a 20-year-old skin cell 24 hours just by changing one gene. So it's never too late in that sense. You have the same genes at 80 or beyond that you had when you were 12 or younger. It's just a matter of teaching your body how to use those genes again. But with respect now to something more specific, which would be the treatment that Paul has undergone and that I myself am undergoing now as an enrollee in my own trial, TRIIM-X, we think that this treatment is likely to benefit people at least out to the age of 80 or so based on animal studies. And actually, one guy got into the trial at the age of 80, right before he turned 81. And he came within a hair's breadth of being disqualified because we have an 80-year-old cutoff. But he got in. So he's now 81. He's been in the trial for a few months, and he's beating other people in his age group at these cross-country running meets that he likes to participate in. He's beating his own personal best records also now. And we had somebody else who was not quite as old as that, who increased his muscle strength quite a bit just by being in the trial. So
Wow.
actually, there was a 77-year-old woman whose least plasma pheno age went back 5 years very quickly after getting into the trial. So
Mark,
there's
that was
so many
Greg.
things we don't know, but I would say don't give up hope. There's still hope.
So Martin, that was Greg's punchy answer, like he said. So just imagine his non-punchy emails. Hey, Greg,
All right.
I think you should specify any age minimum too.
Oh, wow.
Yeah, well,
Machines.
presently our age minimum is 40.
I see.
We don't really think you need it if you're younger than 40, although people have inquired, and maybe someday we'll go there. But I regenerated my own thymus in about a month when I was 46. So I think if you're in your 40s, you're going to respond pretty well. And as long as you can reverse things, you don't have to prevent them. I think prevention is always good, but since this is a new treatment, a new experimental thing that we're doing, we don't want to risk people's health when they don't really need it. So we've established a young age limit of 40 so far.
Okay.
And one of the things, Mark, one of the things we're looking to do is, now that we've shown that we can regrow the thymus, is to then go on maintenance doses and keep it that way.
Wow, that's really exciting. So
yes.
Cali Kid said something weird down below, but anyway, that's his question. Dialysis machines. What does that have any play in doing any of the work you're doing?
Dialysis machines?
Yeah.
No, I think what he may be thinking of is plasmapheresis machines, which are a little bit similar. So with dialysis, they take your blood out, they put it through an artificial kidney, and they put it back in, and that takes the poisons out of your bloodstream. But with plasmapheresis, you can take the blood out of your body, remove the plasma, throw it in the wastebasket, replace it with a salt solution, and put that back into your body. And that's supposed to rejuvenate you, at least according to Irina Convoy's study. I think that the human side of that has not played out as well as we had hoped. Even her rodent study was not perfect, but it did show a reversal of certain features of brain aging. And obviously, brain aging is very, very important. So if we can capture a brain de-aging benefit by plasmapheresis, that would be a good thing to do.
And one of the unanticipated benefits of our TRIIM trials has been the effect on the kidneys as well.
Oh, how about that? So we just lost him. I knew that would happen because he was making some sputtering noises. So is there an age limit to how many years biological age can differ from chronological age? Are you able to answer that, Paul, or did I put that up too late?
Yeah, I think that's a function of how old you are. I think the older you are, that disparity can get higher. But like Greg said, it really helps to start early. I think there's a certain amount of reversal or repair that you can do once you've already had that much aging happen. So I don't know of any specific number, but I think the underlying message that Greg said is that right now our ceiling is 80. That may increase, but if you're 80, like Greg said, whatever age you are, all your cells know how to be young. That's a really kind of inspirational message. I hadn't heard that before. So that means that we just need to find the right technique to remind your cells how to be young. And then that can produce a very large disparity between your biological and chronological age.
So do you think is there a turning point? Let's talk about the thymus itself. Is there a turning point where it's just too late and that cannot be, revitalized?
Well, Greg mentioned 80 is our cutoff now, and that's not necessarily because we don't think it will help after that. But when we're doing these trials, we're publishing the results. So one of the choices you have to make is that you really want people that you think will respond quite well. And I think the older you get past 80, there's other factors that come into play where it's just not so much under control. But, if somebody were to come to us, let's say they're 83 or 84 with very strong health, I think we would still consider them. And there's also things they can do on their own without being an official participant in the TRIIM trial. There's a lot of things like NAD and metformin that people can do on their own with the supervision of their own physician.
Mm-hmm. So, and wrapping this up, Paul, is for the average listener out there, someone that is not willing to participate in the trial or can't, I know there's a little bit of a cost to it, but for the average person out there, if you were to give advice for just plain longevity, would it be everything we basically covered already?
Yeah,
Like
I think it really,
yeah.
I think it goes to sleep, nutrition, I think fasting.
Well, wait, stop right there. Sleep, that's something we haven't talked about.
Yeah.
And I know that if someone is getting very poor sleep in their life, that can really shorten your life. So that's really important. To sleep without using, being dependent on something, that's really hard sometimes.
Yeah, especially as you get older. I think, there's the biological drive to sleep. As soon as you wake up, the body is increasing that physical urge to sleep. And it, with life being hectic and artificial lights and screens and things like that and stress, it gets harder to sleep. And maybe you have to go to the bathroom, etc. So I think the big three are sleep, nutrition, and some form of exercise. Just, time-tested things that we know are very important. And there's just more and more research that if you don't have good sleep, the other things that you do aren't going to have that much impact. And then I think on top of that is some kind of fasting, whether it's, intermittent where you don't have breakfast like I do, or you do the 23 hours or I've done like a 10-day fast as well. That has a lot of good evidence in mammals. And you and Greg bandied around some of the other specific things you can do. But it's really taking care of yourself as more of these things like the TRIIM trial, which was not available 5 years ago, become available for people with, average economic means. There's so many things happening now that you can start doing besides that kind of like holy trinity of sleep and exercise and nutrition, that it's just increasing exponentially for everybody right now.
What was that movie? I can't remember. It was Button something where the guy reversed age.
Benjamin Button.
Benjamin Button. That's what I'm going to start calling you, Paul. But anyway, thank you so much. It's been a real pleasure. Always fun talking to you, Paul.
Likewise, Martin, my pleasure.
All right. And I hope the trial continues to go on and you get younger and I won't even recognize you anymore. But
anyway. Do you see the bulge of my thymus right here?
Oh,
I had to tailor my shirt.
Pumping iron. Yeah. All right, man. Take care.
All right. Bye.
Bye now. All right, everyone. So we'll see you next time. Again, if you want to check out when we have our shows, the best way to do that is simply click subscribe down below. It's free. And to our YouTube channel and click on the notifications. Thank you so much for joining us tonight. I thought it was fascinating. I hope you thought so as well. And see you next time.